Hi there. Today we're going to discuss proportional and non-proportional relationships. Objectives and standards. Today we are going to identify proportional and non-proportional relationships in tables and graphs. Then we're going to describe a proportional relationship using an equation. Vocabulary that you're going to need to know for today is proportional, constant of proportionality, and non-proportional. Identify proportional relationships. Two quantities are proportional if they have a constant ratio or rate. The constant ratio is called the constant of proportionality. In this example, we have total costs and number of wristbands. So if I set up these ratios 6 over 4, 9 over 6, 12 over 18, and 3 over 2, all of these equal 3 over 2. Therefore, they all are proportional because they have a constant ratio of 3 to 2, and the constant of proportionality is 3 over 2. In this example here, for total cost and number of necklaces, 6 over 4, 10 over 5, and 5 over 16, when you simplify them, they don't equal each other. Therefore, they're not proportional, and they would not have a constant of proportionality. The total cost is proportional to the number of wristbands purchased. The constant of proportionality is 3 over 2. However, the rates of the necklaces are not constant. For relationships which the ratios are not constant, the two quantities are said to be non-proportional. So what you're going to look for is a constant ratio. If they have a constant ratio, it's proportional. If they don't, it's non-proportional. How to determine proportionality. Step 1, set up the ratios. Usually they'll provide it for you. They'll tell you how they want you to set up the ratio. If not, they would give you a table. And if they give you a table, you're going to set up the ratio y over x, meaning the second item in the table over the first item in the table. You're going to simplify each ratio in step 2. Step 3, if they are all equal and the same number, it is proportional. That number is called the constant of proportionality. If they don't equal the same number, it's non-proportional. Here's example number 1. Determine whether the cost of coffee is proportional to the number of pounds. If the relationship is proportional, identify the constant of proportionality. Explain your reasoning. So in this example, they're asking you for a few things. The first thing they're asking for, is it proportional or not? And you have to explain that. And if they have a constant of proportionality. Like I said before, they usually tell you how they want you to set it up. So you're going to say cost of coffee over the number of pounds. Again, in a table, usually the first one is your x, the second one is your y. So y over x, or cost over coffee. So I'm going to write the ratio of cost over coffee, so 3 over 1. 6 over 2, which equals 3 over 1, 9 over 3, which equaled 3 over 1, and 12 over 4, which also equaled 3 over 1. So all of these ratios that we formed from our table are all equal. So in that case, that means that the rates are equal, so the cost is proportional to the amount of coffee. So the constant of proportionality, which means the number that is the ratio, or the number that you're multiplying x by to get y. Like here we multiplied 1 times 3, we got 3, 2 times 3, we got 6, 3 times 3 is 9, 4 times 3 is 12. That's your constant of proportionality, the number you're multiplying your x by to get y. And we'll go through that in a little bit. Here's another example. Determine whether the cost of baseballs is proportional to the number of baseballs. If the relationship is proportional, identify the constant of proportionality, explain your reasoning. Okay, so again, our first one is usually our x, second one is our y. So we set up y over x, and just like they said here, cost over number. So we set up the ratio, total cost over number of baseballs. So we're going to have 2 over 1, 3 over 2, 4 over 3, 5 over 4. And these are all in simplest form, so we can't simplify them anymore. So no, it's not proportional because all of the ratios are not equal. So we don't have to find a constant of proportionality. Example number 2, determine whether the distance is proportional to the time traveled. If the relationship is proportional, identify the constant of proportionality and then explain your reasoning. Again, they want to do distance over time. Again, y over x. So we're going to write the ratios. So 50 over 1, 70 over 2, 90 over 3. And if you'll notice, 50 over 1 is simplified, 70 over 2 is 35 over 1, and 90 over 3 is 30 over 1. So all these rates are not equal. So if they're not equal, it's not proportional to the distance is not proportional to the time. And you can just go further when they're saying explain your reasoning. You can say all of the rates or all the ratios are not equal. Here's another example. It says determine whether the number of meters is proportional to the number of seconds. If the relationship is proportional, there's a typo here. Identify the constant of proportionality. Explain your reasoning. Okay, so again, our time is our x, our distance is our y. So we're going to set up y over x or distance over time. And then, so we're just going to set up 24 over 1, 48 over 2, 72 over 3, 96 over 4. So when we do that, all of the ratios equal 24, meaning that the constant of proportionality is 24. We multiplied every single one of these seconds by 24 to get our distance. So, yes, the relationship is proportional. The constant of proportionality equals 24 because all of the ratios were equal to 24. Okay, now we're going to use proportional relationships. Proportional relationships can also be described using equations in the form y equals kx, where k is the constant ratio or constant of proportionality. So in other words, k is the number you multiplied x by to get y. All right, I'm going to just refer back to the last example here. This was our last table. So here we set up the ratio y over x, and we got 24 for each of them. So 24 over 1 equal 24, 48 over 2 equal 24, and so forth. And in the same token, we can say 24 is the constant of proportionality. So we multiplied 24, which is the time, times the time and got the distance. So our equation is y equals 24x, where k equals 24. Okay, so in the form y equals kx, k is the number you multiplied this number by to get these numbers. And we get that number by setting up the ratios. I'm going to give you like 2 examples on this. So it says here, a circle's circumference is proportional to its diameter. Use the figure to find the constant of proportionality. Then write an equation relating the circumference of the circle to its diameter. What is the circumference of a circle with a 6-inch diameter? So this is a lot right here. There's so many things that they want you to do. They want you to find the constant of proportionality. Then they want you to write an equation. Then they want you to find a circumference of a different value. Okay, so the first thing we're going to do is find the constant of proportionality. And they said the relationship is circumference to diameter. So we set up our circumference over our diameter, which was 12.56 over 4, and we got 3.14. Okay, so that means we multiplied 3.14 times 4 to get 12.56. All right, so we have the circumference is 3.14 times the diameter. We're going to let C equals circumference and D equals diameter. So we're saying our circumference equals 3.14 times our diameter. So like we said before, 3.14 times diameter. So we're going to start with our equation. At this point, we have our equation, and now we're just trying to find for the 6-inch diameter. Now we're going to substitute our diameter with 6, and we get, sorry guys, we get 18.84. So the circumference of a 6-inch diameter is about 18.84 inches. Just want to review what we did real quick. We found the constant of proportionality by setting up a ratio. From the ratio, we got our constant of proportionality, and we made an equation. After we made an equation, we used it to find a different value. I'm going to do one more example with you, and hopefully you won't be so confused. Okay, so Nina charges $34.50 for 6 days of pet sitting. Find the constant of proportionality. Then write an equation relating the cost of pet sitting in the number of days. What would be the cost of pet sitting for 4 days? Again, they gave you a ratio or a rate. They want you to find the constant of proportionality. Then when you do that, you want to find an equation. After you find your equation, then you can find as many different values as you want, but here they only want 4. So I set up the ratio of cost over days, and that equaled 34.50 for 6 days. Now, after I simplify this ratio, I find out that it is $5.75 for 1 day. Okay? $5.75 for 1 day. So that means you multiply each day by $5.75. Okay, so the constant of proportionality is going to be $5.75. All right, so now what we're going to do is we're going to use this information and make an equation. So it means 575 times the number of days is going to equal our cost. So our equation is C equals 5.75D, where C equals cost and D equals number of days. From that point, we can now find our future values. So we're going to write down our equation, C equals 5.75D. Then we're going to substitute what we want. We want for 4 days. Then we can multiply, and that equals $23. So 4 days is going to cost $23. Again, this is what we did. We set up a ratio. We found out how much it is for 1 day. We used that information to find the constant of proportionality. And then from there, we made an equation. And then from there, we used our equation. Today, we identified proportional and non-proportional relationships in tables and described the proportional relationship using an equation. Hope that video was helpful. Thank you. Bye.